Hey there guys, in this video we're going to take a look at the mastery test for the first lesson in our Unit 1 on circles. And taking a look at number 1, they want us to, in this figure, find the measure of angle BDA. So if I start marking the things that they're asking me for, I've got BDA right there. So we've got to think about our angle vocabulary and what type of an angle that is. That angle is an inscribed angle. It's inside the circle. Its vertex is on the side of the circle, and the sides of the angle are on both go through the circle. So that's an inscribed angle. So they want us to find the measure of angle BDA. And the only thing that they give us to work with for this is the fact that this angle right here, BOA, the outside of that angle is 250 degrees. So we've got to figure out a way to get the 250 degrees to work its way over to that angle right there. So if we look, this is our inscribed angle. Along with inscribed angles, we also have central angles that we can work with. So if I outline the central angle, it's right there. And we know that these two angles intercept this arc right here. So if we look, we've got an arc AB that goes from there to there. So because both of those angles intercept that same arc, there's a relationship between them. But first, we need to find the measure of this angle here on the inside. So if we remember, a circle is going to be 360 degrees. So all the way around the circle is 360 degrees. And if we only want that part, we're going to do 360 minus that 250. And that gives us 110. So then if we're looking and we know that this angle is 110 degrees, then the measure of this arc is going to be 110 degrees. So then the only thing you need to do to figure out the measure of this angle there is remember the relationship between our central angles and our inscribed angles, and that will give you that number. Then the second part of this question wants us to find the measure of angle BCA. So if we find there's B, there's C, there's A. So it's asking us for the measure of this angle right here. This is not something that we covered in class, but it is something that the rule isn't too hard for it. If you look, we've got BCA right there, but then if we go and connect this here, we have a quadrilateral. And I know for our inscribed quadrilaterals that our opposite angles are supplementary, that also works for a quadrilateral that is created using the central angle and the two lines that intersect that make tangents. So this angle right here plus that angle right here are going to add up to be 180 degrees, and you just need to figure out the measure of that one. Right, looking at the second question. This one is something that we didn't cover in class, and it goes above and beyond the level that I would like for you to do for this one. So feel free to give it a try, but if you'd like to double check your answer, there you go. First one's ABO, and second one is BCO. And something that you need to keep in mind whenever you're looking at these questions, I've got pretty much the whole question bank, and you won't have all of the questions, and your questions are not going to be in the same order that mine are. So if you're stressing out because your questions don't match and you're not seeing the ones that I'm doing match up with yours, you're not doing anything wrong. It's just mine are in a different order than yours are. So just be patient with it, and you'll find what you're looking for through either a hint or me giving you the answers like you're looking at for this one. All right, looking at 3, or the third one that I have on my list. This is not something that we covered in class, and I know the lesson went through it and did it, but I'm just going to go ahead and give you the answer for this one. The answer is 53, or C. I don't know if your multiple choice is going to match up and be the same exact as mine, so double check and make sure you are picking the 53. If we take a look at the next one. I started to really like this question and think that it was a good one, but then I noticed while they gave you AE and DE, which was great, they did not give you either of those whole entire chords. They only gave you that the diameter, or sorry, the radius is, that the radius is 5 units. So that's not enough. We need more information. The lesson may have walked you through how to do that, but that's not a level that I would expect you to be able to do that question. So looking at this one, the answer is 5.5 or A. All right, looking next at 5. This is another one of those. They took it one step further than we did in class. The answer for that one is 85 or C. The next one on my list, I like this one. This one is a good one. So they tell us that in the diagram, point O is on the center of the circle. If the measure of angle ABC is 70 degrees, what is the measure of angle AOC? So you just got to look and think, okay, what type of angle is angle ABC? If I look at it all by itself, what type of angle is AOC? Do they both intersect the same arc? What is that relationship? And if you're looking for kind of a talk through on that hint again, that was back on that first problem that I worked through with you guys. But I think that should be enough to get you through that one. Looking at the next one, I kind of like this one. This one has you use some of our polygon rules that we used. So looking at this one, they tell us that AF is a side of a regular hexagon ABCDEF. And it's inscribed in circle O. What is the measure of angle FDA? So if we're looking for what they're wanting us to solve for, they tell us that we're solving for the measure of angle FDA, and FDA is right there. So that means we're looking for the measure of that angle right there. So I'm going to outline this angle. And then we also have to remember regular hexagons. What does it mean for a hexagon? Hopefully you remember that means it is 6 sides. And then what does it mean for it to be regular? And that's going to mean that all sides and angles are equal to each other. So if we take this hexagon and we inscribe it or put it inside of a circle, that's going to make, from there to there, that's going to create arcs that are all equal to each other. It's going to divide it evenly. So looking at all of those little arcs, all of those arcs are going to be equal. So I can take the whole entire circle that we have that we're working with, that 360 degrees, and divide it by 6 to get the degree of that arc, what we're working with. And when we do that, we get 60. Each of those arcs are going to be 60 degrees. So then all you need to think about is, what type of an angle is this? That's an inscribed angle. And then how is that inscribed angle related to that arc? And then that will be able to have you get that answer right there. Looking at the next one. This one is another one that I like. So looking at this one, they tell us that in the diagram AC, that it's a diameter of a circle with the center at O, and the measure of ACB. So I'm going to outline this stuff. So ACB, so that whole thing right there is 50 degrees. What is the measure? So there's my ACB. What is the measure of BAC? B, A, C. So there's a couple ways you could go about it. Probably the shortest that you could do that would get you to the answer the quickest is we talked about this very briefly in class. It wasn't anything we ever really defined with a definition or did very specific examples on, but there were problems that would pop up in the notes or pop up in the homework, and I would say, hey, in this case, there's this rule. But anytime that you have a triangle where one of the sides is the diameter, that you are going to have a right triangle. And it doesn't matter where this point is on the circle. As long as this right here is your diameter, then you're going to be looking at a right triangle. So then you can use your triangle sum theorem. You could do your 90 plus 50, subtract that from 180, or you could just use your right triangle rule that, whatever this angle right here, this BAC that they're looking for, that's going to be equal to 90 minus 50. Taking a look at 9. So we didn't get very much of a chance to get into this. And looking at this, all this is it's showing us we've got two circles here, and we've got two lines that are intersecting outside of our circles. But something neat is happening with those two lines. Both of those lines are tangent to both of those circles. So this what they're trying to show you is that no matter what you do with that circle, as long as it's somewhere inside of these lines. So like we could take this circle and scooch it out and have its sides still touch those tangents, no matter how far we scooch it out or how far we scooch it in here, as long as we still have a circle, the measure of these two central angles that they have going on there are always going to be equal and congruent. And that's how circles work. All circles, and this is how we did dilations for similarity whenever we covered that chapter. We kind of used that point and expanded it out from there, and that's what they're doing here. So the answer for that one is going to be B, 140. Looking at that last one that I've got, this one kind of is one that I would have put before that first question that we worked together. So it tells us that point O is the center of the circle in the diagram. What is the measure of angle BCA? So remember we talked about how we've got this quadrilateral, and that with this quadrilateral, if you're looking, and this isn't true for all quadrilaterals, it's only true for ones that are inscribed within the circle and ones that can be made with the central angle and two tangents. But either way, they're looking for BCA. Opposite angles in a quadrilateral are going to be supplementary, and you don't have this angle here. But what they do give you is they do give you this angle right here. So you've got to do that 360 minus the 250 to give you this angle right here, and those two are supplementary. So you've got to do this angle here plus this angle here is going to be equal to 180 degrees. Solve that, and that will give you your angle of BCA. Okay, so there's your walkthrough for the mastery test for the first lesson in our Unit 1 circles. Hopefully this has helped you get through it okay. If you still have any leftover questions or you need help, just shoot me an email or pop in during my virtual office hours. The links for that are available in the spreadsheet, and those links usually don't go live until around office hours time. So either way, I hope this helped, and if it didn't, I hope to hear from you soon. Take care.